Okay, so let's quickly refresh our brain about properties just to make sure we've got that down. Letter A, what property is being illustrated? When something's congruent or equal to itself, that is the reflexive property. And whether it's reflexive property of congruence or reflexive property of equality, it's the same thing. B, what's happening from your hypothesis to the conclusion?
Is it simplified?
Not simplifying.
Addition.
Addition. We're adding 8 to both sides, right, to get rid of the minus 8. So addition, All right. C, if line segment RS is congruent to line segment TW, and line segment TW is congruent to line segment PQ, then it must be true that line segment RS is congruent to line segment PQ. What property is that? Transitive. Good. And then the last one, if the measure of angle A equals the measure of angle B, then the measure of angle B equals the measure of angle A.
Symmetric.
Yeah, symmetric, your symmetry one. So symmetric property. Okay. So that sounded pretty good. I feel like we have those pretty well taken care of. All right, so we've talked about postulates, right? Postulates were statements that we just say they are what they are without any proofs. Now we're going to be adding some theorems into the mix as we continue throughout this course. And a theorem is a true statement that follows as a result of other true statements. Okay, so when we do our proofs, we start with something. We do a whole bunch of logical arguments to get something at the bottom. And that's how theorems are created. They start with something that we already know, as like some type of postulate, and you do your proofs to it, and you get to a theorem. So any theorem that out there has some type of proof beyond it. Okay? So difference between a theorem and a postulate. Postulate is true without any proof. A theorem needs to be proved in order for it to be true. All right, so we're just going to do a whole bunch of proofs. And we're going to be lazy about it because it's going to be a lot of writing for the rest of the class. All right, so here we go. Set up our T-chart. Just do S and R's for statements and reasons. We'll be lazy for notes. Try not to be lazy for your test. Line 1 is always our given. So what are we given? We're given angle CBE is congruent to angle DBA given. Now our ideas for how to do a proof still are the same. Do you see any vocabulary words anywhere in that given? No. So since I don't see anything like a linear pair or bisecting or midpoint or vertical angles or supplementary or anything like that, then my go-to is going to be to one of my addition postulates, right? That's where we always fizzle back to. So if I don't have any vocabulary, then go to angle addition or segment addition. What's the case up here? It's going to be, Samson?
Would it be, or would you do the if it's congruent, then it would be equal?
Well, we're eventually going to have to, yeah, because you notice here I have congruence and I need my last line to have equals, so eventually we're going to have to do that. But before we have to do that, we need to get some angle addition happening. So what angle additions do we have to do? Well, I got a lot of angles happening over here, right? So I have to figure out what I want my big angle to be. And your clue for what you want your big angle to be would be over here in your prove line. So my first angle listed here on my prove line is angle EBA. So let me highlight that. So EBA is right here. So if I ignore this part, what would the angle addition look like? Well, the measure of angle, so the measure of angle EBA is equal to the measure of angle, so one of the small ones, EBD, plus the measure of angle, what's the next one? DBA. All right, angle addition. Okay, so now I have the measure of angle EBA in play. Now I got to figure out how to get DBC into play. Well, let's look where DBC is. Let me highlight that in a different color. Let's make it orange. So DBC is here. So what would that look like as an angle addition statement? So the measure of angle DBC, which is the big, would be equal to angle EBD. So the measure of angle EBD, EBD, plus the other one, which would be CBE. CBE. Is everybody okay with me putting ditto marks? Would you understand what a ditto mark is instead of writing out angle addition again? Is everybody good with that? You are welcome to do that too if you ever are replicating something from previously above. Okay, so now where do I need to get to? I need to somehow get this angle measure equal to this angle measure. Well, for these two guys to be equal, I need to somehow get this right side to be the same as that right side. Are they the same? Not quite. Almost. What do they have in common, the green parts? They both have an EBD, right? So that's good. I got half the battle done. How can I get these guys to be equal? Well, look what we just set up here. I was told that CBE is congruent to DBA. And what do we know about congruent angles? They are equal. Good. So there's going to be my next move. So we need to somehow get this, so like Samson was saying, we need to get those to look like the measures of. Here, I'll move up here so people can see in the back of the room. Don't need that anymore. Okay, so line number, 4. So line 4. The measure of angle CBE will be equal to the measure of angle DBA. Whoop, what just happened? Cancel. Because if we have congruent angles, then we know that they're going to be equal in measures. Okay, so now, what can I do to my green line 3 to make it look like my green in line 2? We already said I have an EBD here, I have an EBD here. I have a DBA here. Can I turn this into a DBA? What property lets me put something in place of something? Substitution. Good. So now my line 5, which hair? Line 5, I'm going to rewrite my line 3. So the measure of angle DBC is equal to the measure of angle EBD plus, now instead of CBE, I'm going to make it the measure of angle DBA. Because now I can do that because of substitution. Because in line 4, I said that they were equal to each other. So substitution. All right, so now let's get a new color. We'll go purple. Is this right side the same as line 2's right side? Yes. So now my right side is the same as that right side. So what property tells me that if these are the same, I can make these the same? Transitive property. Good. So now I've got it. So line 6. What is the prove line? What's on the left? EBE. We want that first, or EBA. So the measure of angle EBA is equal to the measure of angle DBC because of the transitive property. And that's the end of our proof. Okay, so we're manipulating things to try to get things to look the same. And then once we have this looking exactly like the prove line, then I'm done. Okay. All right, so there was no algebra in there. So we're taking away the algebra part. Could you have done line 4 as line 2? Sure. You could have flip-flopped that and did your if congruent angles then equal measures first, and then did your 2 angle additions, and then your substitution, then your transitive, and that would have gotten you to the same results. Okay, so let's go to number 2. Number 2, now we're dealing with line segments. So set up your T-chart. S on the left, R on the right. Oh, you don't have this one?
I think we're on the wrong one.
Oh, man. Okay. Where are you guys at?
Right
No,
not a right angle.
Yeah,
That one? All right. Okay. So we got a right angle. Well, looks like a right angle. We're proving it's a right angle. That's what we're doing. All right. So statements on the right, statements on the left, reasons on the right. What are we given? We're given the measure of angle CBD is equal to 65 degrees. The measure of angle DBA is equal to 25 degrees. Given. All right, so do we see any key vocabulary words? No, we do not. So if I don't see any vocabulary words to give me any direction, then we always go back to either angle addition or segment addition. In this case, we're going to do angle addition. What's the big angle? CBA. So the measure of angle CBA is equal to the measure of angle CBD plus the measure of angle DBA. Angle addition. All right. So what's nice about this is I'm already in equals, and I need to get to a right angle. So let's think. What do I need to do to make sure I know that it's a right angle? Add the numbers together and make sure it equals 90 degrees, right? Okay, so let's substitute it in. Do we know what CBA is right off the bat? No. So I want it to stay CBA. So 3 is going to stay the measure of angle CBA. We are given CBD is 65 degrees. I'm going to substitute that in. We are given the measure of angle DBA is 25 degrees. So I'm going to substitute that in. So we use the substitution property. What's next?
Addition.
Well, not addition, because addition would be both sides. So what do we call it when we just combine, simplify? Good, yeah. By adding them together. I knew where you were going with that. CBA is equal to 90 degrees. Simplify. So if CBA is 90 degrees, then is it a right angle? Yeah. So let's put that over here in if-then form. Am I getting too low? Can you guys see it in the back of the room? Here, I can come up here for my last line. So line 5 is going to be my prove line that angle CBA is a right angle. And then on this side, I need that to be in an if-then statement. So remember, your hypothesis comes from the previous step. So what do I have up here? Generalize it. If an angle is 90 degrees, then it's a right angle, right? Is what I'm going to write over here. So if an angle is 90 degrees, then it's right. Something like that. James?
Before, is it CB or DB?
CBA. Yeah. I know it's all blended together there. Fat fingers doesn't help. Alrighty. That one was a lot less steps than the previous one. All right, make sure we're going with the same one together. All right, we got another right angle, it looks like. So let's go ahead and set up our statements and reasons T-chart. I gotta make this a little higher. Statements, reasons. Given angle 1 and angle 2 are complementary, and the measure of angle 2 equals 80 degrees, given. Do we see any key vocabulary words? Now we do. What's the key vocabulary word? Complementary. What? Give me an if-then statement about complementary angles.
Complementary, then 180 degrees.
Not 180. If complementary angles, then add to 90 degrees. Okay, make sure you have that add to. Because some of you guys will just write it's 90 degrees, and that's not right. That's right angles. Okay, so we just made a conclusion that they're going to add to 90 degrees. So that means over here, I need to show those two angles adding together to 90 degrees. So the measure of angle 1 plus the measure of angle 2 is equal to 90 degrees. What's next? Good. Substitute in what, Owen?
Angle, or 80 degrees for angle.
Yeah, so we said in our given that angle 2 is 80 degrees, so substitute that in. So substitution. Ooh, we got one more move. What is it? Subtraction. Good, subtraction. So the measure of angle 1 is equal to 10 degrees. Subtraction. That was a pretty easy one. Property of equality. Anything too crazy? I bet you I know what happens. I think I didn't do double-sided when I printed these out. I don't know. Maybe lucky for you guys and not lucky for me. I don't know. So you probably don't have this guy either, huh?
Nope.
All right. Or that guy. Or that guy. That's okay. I'll just give you extra time to practice. Okay, here we go. Last one. My error. All right, we got a lot of stuff happening in our givens. We got ray BE bisecting angle TBV. And we're given that angle 1 is supplementary to angle R. Given. Okay. I see two sets of vocabulary words here. Which one do we want to work with first? Bisecting first? Okay. So what do we know about something bisecting something? Cuts it in half, but more specifically, two congruent parts, right? So let's get that in an if then. So if angle bisector, then congruent angles. So my conclusion over there was I had congruent angles, which means on this side I need to show which angles were congruent. Well, the nice thing is, here I threw numbers in for you, so we can just use the numbers instead of the letters. You could use the letters, but notice I have 2 in there, so we'll keep it there. All right, so angle 1 is congruent to angle 2. Okay. Let's see, where else do we gotta go? We're told that angle 1 is supplementary to angle R. So what does that tell me?
That R and angle 1 make 180 degrees.
Good, they add up to 180. So now let's think about this. If I were to do the supplementary part, so if we did if sup, then add to 180, what would I have over here? Would I have equal signs or congruent signs? I would have something plus something equals or congruent to 180? I would have it as equals, right? So I probably, before I continue on, should probably move number 2 to equals. So how do I turn congruence into equals? If congruent, then equals. So let's make that our line 3. So if congruent, then equal. It's a really lazy version of it. So then what would I write over here in the third line on the left? The measure of angle 1 equals the measure of angle 2. Okay, so now I have that all set up in equals, so that's good. So now let's take care of the supplementary component, which we already kind of started talking about it. Let me get up here to the top so the back of the room can see. I miss having my horseshoe of you guys so everybody can just see the board. Okay, so line 4, we were told that 1 and R were supplementary, which means that the measure of angle 1 plus the measure of angle R is equal to 180 degrees. So if sup, then add to 180 degrees. All right, so let's think backwards. My proof line needs these two guys to be supplementary. So in order for me to prove them supplementary, what must be true about angle 2 and angle R?
They are congruent.
Not congruent, not equal to each other. Up here we just said if they're supplementary, then they add up to 180. What's the converse of that? If they add up to 180, then they must be supplementary, right? Which is where I need to go. So if I need to prove that these are supplementary, then above this, I need to show that they add up to 180 degrees, right? Well, right now I have 1 and R adding up to 180 degrees. How can I show 2 and R adding up to 180 degrees? Substitution. Didn't we just say that they're equal to each other right here? All right, so line 5, the measure of angle 2 plus the measure of angle R is equal to 180 degrees because of substitution. Oops, I zoomed in too much. Substitution property. So now can we say that they're supplementary? Yes. So my last line is the proof line. Angle 2 supplementary to angle R. And then keep in mind that your conclusion should directly relate to this. Your hypothesis should talk about what's in the step before. So generalize it. If angles add up to 180 degrees, then they are supplementary. So if angles add to 180 degrees, then supplementary. Okay, and then we're done because I got the proof line as my last line. So when you think about those if-then statements, your hypothesis should always match up with what happened right before. Your conclusion should match up with directly that's there. Okay, so what I'm going to have you guys do for the remaining